All right, so welcome to the meat and potatoes. We're going to start lesson 1. This is what I'm going to need to have ready by Monday. So it looks like it's just a video to start with. So let's just watch the video, and then when we're done, perhaps read the notes, take a look at lesson 2. But I think that's all we're going to need to do is just lesson 1 here. And one thing I'm noticing is it is an hour and 22 minutes. So I might need to split this into 2 videos, but let's try to get through as much as possible.
Hello everybody, and welcome to Deep Learning for Coders, lesson 1. This is the 4th year that we've done this. But it's a very different and very special version for a number of reasons. The first reason it's different is because we are bringing it to you live from day number 1 of a complete shutdown, or not complete shutdown, but nearly complete shutdown in San Francisco. We're going to be recording it over the next 2 months in the midst of this global pandemic. So if things seem a little crazy sometimes in this course, I apologize, but that's why this is happening. The other reason it's special is because we're trying to make this our kind of definitive version, right? Since we've been doing this for a while now, we've actually finally gotten to the point where we almost feel like we know what we're talking about. To the point that Sylvain and I have actually written a book. And we've actually written a piece of software from scratch called the FastAI Library version 2. We've written a peer-reviewed paper about this library. So this is kind of designed to be like the version of the course that is hopefully going to last for a while. The syllabus is based very closely on this book. Okay? So if you want to read along properly as you go, please buy it.
All right, so there's a lot of starts and stops in his language. It looks like this is just an unedited, uncut kind of stream of consciousness. Maybe there's a script, maybe there's not. But long story short, we're going to put this in double rate. And once it starts to go into content, we might slow it down. But for now, we're just going to watch this in double speed.
Please buy it, because actually the whole thing is also available for free in the form of Cuban notebooks. And that is thanks to the huge generosity of Riley Media, who have let us do that. You'll be able to see on the website, of course, how to access all this. But here is the passport repo where you can read the whole damn thing.
Okay, so that's going to be important to know. So let's find that. Hopefully it's in the notes somewhere. I don't see that it is. So let's slow down the video and go back and look at the and try to find that link. So we're going to go back to regular speed. We won't need captions, and then we'll pause it once he shows that link.
But here is the fun.
Okay, so here's the link. It's a GitHub link. So it's /FastAI/Fastbook. Perfect. Okay, so I'll be bookmarking this. All right, so now let me make sure. Yep. All right, so let's keep going. I think I can
Fastbook repo where you can read the whole damn thing. At the moment, as you see, it's a draft.
I think I can go back to double speed, but I might need to pause pretty quick. But let's go back to double speed.
After, by the time you see this, it won't be. So we have a big request here, which is the deal is this: you can read this thing for free as Cuban notebooks, but that is not as convenient as reading it on a Kindle or in a paper book or whatever. So please don't turn this into a PDF, right? Please don't turn it into better form design, more tradition, because kind of the whole point is that you'll buy it. Right? Don't take advantage of a generosity by creating the thing that they're not giving you for free. And that's actually specifically a license under which you're licensed as well.
Yeah, see, none of this applies to me. I don't even know how to create this into a PDF, so we're watching double speed. Let's continue.
So there's plenty of requests being executed in. If you see something else not being executed in and stealing the book version of the book, please tell them, please don't do this. Not nice. Don't do this. So anyway, you can read along with the syllabus in the book. There's a couple of different versions of these notebooks. Right? There's the full notebook that has the entire prose, pictures, everything. Now we actually wrote a system to turn notebooks into a printed book, and sometimes that looks kind of weird. For example, here's a weird looking table, and if you look in the actual book, it actually looks like a coffee table. Right? So sometimes you'll see like little weird bits. Okay, they're not mistakes, they're bits where we kind of add the information to help our book turn into a nice book. So just now when I say we, who is we? Well, I mentioned one important part of the we is Silvan. Silvan is my co-author of the book, and I started to libraries, so he is my partner in writing here.
Okay, so apparently we're hearing from Jeremy Howard right now.
The other key we here is Rachel Thomas, and so maybe Rachel, you can come and say hello. She's the co-founder of FastAI.
Hello, yes, I'm the co-founder of FastAI. I'm also taller than Jeremy, and I'm the founding director of the Center for Applied Data Ethics at the University of San Francisco. I'm really excited to be a part of this course, and I'll be the voice tutor asking questions for us.
Rachel and Silvan are also the people in this group that actually understand math. I am a mere philosophy graduate. Rachel is a PhD, Silvan has written 10 books about math. So if math questions come along, it's possible I may pass them along. But it's very nice to have an opportunity to work with people who understand this topic so well. Yes, Rachel, did you want to? Sure, I'll think. And as Rachel mentioned, the other area where she's has real world-class expertise is ethics. She is the founding director of the Center for Applied Data.
At the University of San Francisco.
Thank you. We're going to be talking about data ethics throughout the course because
That's really good to hear, because AI ethics is something that's interesting to me, and I think going to be one of the fundamental ethical issues of the next few decades. Obviously, there are bigger ethical issues than just that, but it is definitely going to be one that's not going to go away for a long time. So it's good to get a jump on.
It's very important. So for those parts of the larger be presenting them, they will be on the whole based on.
And like AI, like autonomous vehicles haven't even hit the road yet, and we can have our AIs, our autonomous vehicles, spy on people and stuff. And is that ethical? Like, what if you're driving a car and you witness a crime? Do you have the ethical obligation to report that crime? What if you see someone lighting a building on fire, and you see that they were wearing a LeBron James jersey, and you read on the news, hey, there was arson in this building, and we don't know anything about what happened. Here's the building, and you say, oh my God, that was the building I saw, and I saw a guy in a LeBron James jersey with a bucket of gasoline. Hopefully he's not wearing a LeBron James jersey, maybe a J.R. Smith. Well, anyway, some identifying piece of clothing. Do you have a ethical obligation to call the tip line and say, I saw this guy in this identifiable clothing with a gas can before this arson instance happened as I was driving down the road? People would say different things. I would probably say, yeah, you have kind of an ethical obligation to call that out. So where it gets tricky is, do autonomous vehicles have that ethical obligation? Because they, because I make a judgment. Let's say if I see someone jaywalking, am I gonna, tip that? No. If I see someone like walking their dog without a leash in an area where it needs one, like, am I gonna automatically go and, call the police because they're violating no. So, but you got to be careful when it comes to an AI, because do they know to make those distinctions? So really, the person who develops the AI is the one who makes those distinctions and that it's important that the person who develops the AI understands ethics and how to make the appropriate calls, judgments, and distinctions.
Which is what actually let's talk about. Although I kind of know that I'm talking about too. Okay, so that's that.
Okay, I can't really hear him right now, so it sounds like he's still really not saying anything substantial. But let's bring it down to 1.5 just so I can hear him a little bit better.
So, should you be here, is there any point you were attempting to understand this button?
Okay, so I already read this part where we went through. Yep, so let's just hear what he has to say.
Understand deep learning. Okay, so what do you should you be here? Is there any point you were attempting to learn deep learning, or are you too stupid?
Okay, so I already went through this section, and there's a lot of ums and ahs and pauses, so I'm going to bump it back up to 2.
Or you don't have enough vast resources or whatever, because that's what a lot of people are doing. They say, in teams of PhDs and massive data centers, what GPUs, otherwise it's pointless. Don't worry, that is not at all true. It couldn't be further from the truth. In fact, a lot of world-class research and world-class industry projects that come out of FastAI alumni and FastAI library-based projects and elsewhere, which are created on a single GPU using a few dozen or a few hundred data points from people that have no graduate level technical expertise, or in my case, I have no undergraduate level technical expertise. I'm just a philosophy major. So there is, we'll see it throughout the course, there's lots and lots and lots of clear empirical evidence that you don't need lots of math, you don't need lots of data, you don't need lots of expensive computers to do great stuff to begin with. So just bear with us, you'll be fine. To do this course,
But yet the foundation of his agency has written 10 books on advanced math. So I guess what he's saying is you don't need math, you just need access to people who know math. But I would say that it's not a myth. You do need to know a lot of math, and I guarantee you he knows a lot of math. Like he knows, like he's talked to this lady who has written 10 books, and he has been exposed to a lot of mathematical concepts. Like, do you need a PhD in math? No. Do you need to be able to sit down and derive the quadratic formula? No. But you need to understand mathematical concepts, and you need to understand that there is fact and there is fiction, and you need to understand how we got to fact, why facts are the truth, and the meaning of things. You need to understand that things do have meaning, things do have truth, there are such things as facts. So you need to understand it in really specific ways. So I would say that it's not a myth that you need lots of math. Like you have to have a certain mindset. So I just disagree. Like truth, just high school math is deficient. Well, that means a lot of different things to a lot of different people. When I was in high school, I took calculus AB and I took calculus BC. Now, when I took pre-calculus, I was taking that course with seniors who were taking their final math class in high school. So high school math can mean anything from just barely touching on calculus to taking advanced placements exams on calculus. So it's very unclear what that even means. Just high school math is sufficient. It could mean a number of things. So I really disagree with this. I do think you need, you might not need to know a lot of math. You might not need to know all the symbols, how to manipulate them, what they mean. You might not need to have been exposed to a lot of formulas. But I think you do need to be open to believing math, which a lot of people aren't. And you need access to people who actually do know math, if you don't know it yourself.
To decode. Preferably, you know how to code in Python, but if you've done other languages, you can learn Python. If the only languages you've done is something like MATLAB, if you've used it more for like a scripty kind of thing, you might find it, you will find it going. But that's okay, stick with it, you can learn Python as you go. Is there?
Okay, so this looks kind of interesting. Oh, but I do remember reading this already, so we'll keep it at double speed.
The point learning, deep learning is that you're good at that stuff. If you are hoping to build a brain that is an AGI, I cannot promise we're going to help you with that.
And AGI stands for Artificial General Intelligence.
Thank you. What I can tell you though is that in all of these areas, deep learning is the best known approach to at least many versions of all of these things. So it is not speculative at this point whether this is a useful tool. It's a useful tool in lots and lots and lots of tests. It's extremely useful tool. And in many of these cases, it is equivalent to or better than human performance, at least according to some particular narrow definition of things that you can do in these kinds of areas. So deep learning is pretty amazing. And if you could pause the video here and have a look through and try and pick some things out that you think might be interesting, then type that keyword and deep learning into Google and you'll find lots of papers and examples and stuff like that. Deep learning comes from the background of neural net.
Okay, so this actually looks kind of interesting. Let's slow this down to regular speed and pay close attention to what is being said.
Networks. As you'll see, deep learning is just a type of neural network learning. A deep one. We'll describe exactly what that means.
Okay, so saying that deep learning is a type of learning, a deep one, is really frustrating to me. So we're gonna bump this up to 1.5.
And neural networks are certainly not a new thing. They go back at least to 1943 when McCulloch and Pitts created a mathematical model of an artificial neuron.
Okay, that I really like. It was discovered in 1943 by creating an artificial model based off of a neuron. That I'm happy to have heard.
I got very excited about where that could get to. And then in the 50s, Frank Rosenblatt then built on top of that he basically made some subtle changes to that mathematical model. And he thought that with these subtle changes we could witness the birth of a machine that is capable of perceiving, recognizing, and identifying its surroundings without any human training or control. And he oversaw the building of this extraordinary thing, the Mark I perceptron at Cornell.
Okay, so Frank Rosenblatt sounds pretty freaking awesome. So let's look him up. What is it, Blatt? Yeah. Okay, so he's got a Wikipedia page, of course, because he's freaking brilliant. He invented AI. Or he was a American psychologist, so he knows a lot about the brain, how it works. He was notable in the field of artificial intelligence. So we'll just leave this up. Might come back to it at the end or something. Looks like he won a special award, or no, there's an award that is given out in honor of him. That's the key. Like, you can win every award you want, but until you've got a award given out in your honor, you know how just how smart and significant are you. But let's just continue on.
So that was, I think, it was 1961. Thankfully now.
Okay, it looks like I'm having a lot of issues with the environment here. I'm not allowed to reduce these, even though it says you can collapse the sidebars on the left and right by clicking the arrow icons at the top next to each item. So there are no arrow icons. So that is not the truth. It is in fact a lie, and it looks like I accidentally minimized the screen, so I will try to unminimize it. And there we go. We got this maximized. So it looks like there's another issue where when I click maximize, it doesn't take up the full screen. But I do have the full screen here, so this is all I needed. So let's continue watching, and we'll continue watching at 1.5 because I can hear what he's saying, but it's still sped up significantly.
In case we don't have to build neural networks by running the damn wires should we come to neuron, artificial neuron, but you can kind of see the idea, a lot of connections going on. You'll hear the word connection a lot in this course because that's what it's all about. Then we had the first AI winter, as it's known, which really, to a strong degree, happened because an MIT professor named Martin Minsky and Harvard wrote a book called Perceptrons about Rosenblatt's invention, in which they pointed out that a single layer of these artificial neuron devices actually couldn't learn some critical things. It was like impossible for them to learn something as simple as the Boolean XOR operator.
Okay, let me read this first. So an MIT professor named Martin Minsky, who was a grade behind Rosenblatt at the same high school, along with Seymour Papert, wrote a book called Perceptrons about Rosenblatt's invention. they showed that a single layer of these devices was unable to learn some simple critical mathematical functions such as XOR in the same book. They also showed that using multiple layers of the devices would allow these limitations to be addressed. Unfortunately, only the first of these insights was widely recognized, as a result of which the global academic community nearly entirely gave up on neural networks for the next 2 decades. Yeah, that's really, I think, kind of fascinating, because there's something called emergence, where any one particular element is not doing anything all that sophisticated, but together emerge these really sophisticated things that any single piece is not capable of doing. They're only capable of doing it if they all come together, and that property emerges from them doing these simple things together. So I'll just leave that to whoever may be watching this to look that up themselves. Yep, so it's right here. So whole Wikipedia page on that. Let's look up this book, Perceptrons. Okay, and let's see if there's like an Amazon. You can buy it from Amazon. It looks like you can. So yeah, and it even got good ratings. So yeah, we could buy this book on Amazon and read the book. Yeah. Okay, so let's continue watching the video.
In the same book, they showed that using multiple layers of devices actually would fix the problem. People didn't notice that part of the book and only noticed the limitation, and people basically decided that neural networks are going to go nowhere, and they kind of largely disappeared for decades. Until, in some ways, 1986. A lot happened in the meantime, but there was a big thing in 1986, which was MIT released a thing called a book, a series of 2 volumes, a book called Parallel Distributed Processing. In which they describe this thing they call parallel distributed processing, where you have a bunch of processing units that have some state of activation and some output function and some pattern of connectivity and some propagation rule and some activation rule and some learning rule operating in an environment. And then they describe how things that met these requirements could, in theory, do all kinds of amazing work. Now this was the result of many researchers working together. There's a whole group involved in this project, which resulted in this very important book. And so the interesting thing here to me is that if you, as you go through this course, come back and have a look at this picture, and you'll see we are doing exactly these things. Everything we're learning about.
Okay, so it sounds like he's saying that this is a really important picture to take note of during the course. It kind of simplifies all the things that are happening. So let's screenshot this and find a way to save it. So we're going to do, we're going to save it to the desktop, and we're going to do course simplified course, or we'll say machine learning simplified. Okay. So that's going to be a PNG file. So now I'll go to my Google Drive and I will save that. So first I've got to switch over to my other account. Okay, and now I can do. Oops! So it didn't successfully switch over. So I'll try it again. Perfect. Okay, so now I'm going to do new. I'm going to do file upload. There we go. Machine learning simplified. So we've got that to go back and reference. Oops, we've also got this spam here. So let me see if I can remove it. Perfect. Okay, so yep, we've got machine learning simplified. Let's make a new folder specifically for this course I'm working on. And I forget the name of the course right now. Let me go to my YouTube channel and hopefully find the name of it. Okay, so it's called Practical Deep Learning for Coders. So if I can please just copy paste that. Thank you. Okay, so I've got a new folder. We'll move this down there. Hopefully it'll still work. We might have some performance issues. And then I'll move this as well, if I may. So we're going to do move to, and it's going to be this one, move. Okay, so now we've got everything organized really nice in this folder. If I do another course or something in the future, they will be partitioned, or they'll be in different folders. All right, so let's continue on.
Really is how you do each of these activities. And it's interesting that they include the environment, because that's something which very often data scientists ignore, which is you build a model, you've trained it, it's learned something, what's the context it works in. We'll be talking about that quite a bit over the next couple of lessons as well. So in the 80s, during and after this was released, people started building in this second layer of neurons, avoiding Minsky's problem. And in fact, it was shown that it was mathematically provable that by adding that one extra layer of neurons, it was enough to...
Okay, let me read this, because I think what he has written here is pretty good. So this is the age of deep learning is here, and in the 1980s, most models were built with a second layer of neurons, thus avoiding the problem that had been identified by Minsky. However, again, a misunderstanding of the theoretical issues held back the field. Why didn't they just ask, what's his name? Yeah, why didn't they talk to Frank some more? Like, he knew all that crap, didn't he? Why did it take him until the 80s to understand it? Oh well. Alright, however, again, a misunderstanding of the theoretical issues held back the field. In theory, adding just one layer of neurons was enough to allow any mathematical model to be approximated with these neural networks. But in practice, such networks were often too big and... Okay, that really scared me. But what it was is my door, if I don't close it all the way, and the air conditioning comes on, gets closed by the pressure changes in here. But it scares me a lot when it happens, even though I know what's happening. It's just, you know, I'm a product of evolution. And if I hadn't gotten scared like that, I would not be prepared if there were a predator. But I'm one step above a product of evolution because I understand more than just those basic instincts, and I have a neuro cortex that can understand that there are pressure changes in the room, and those cause the door to close. And I can learn about machine learning. So let's keep doing that. But in practice, such networks were often too big and slow to be useful. Researchers showed 30 years ago that to get practical good performance, you need to use even more layers of neutrons. Neural networks are now finally living up to their potential thanks to the understanding to use more layers, as well as improved ability to do so thanks to improvements in computer hardware, increases in data availability, and algorithmic. So algorithmic improvements. We now have a machine capable of perceiving, recognizing, and identifying its surroundings without any human training or control.
Allow any mathematical model to be approximated to any level of accuracy with these neural networks. And so this is like the exact opposite of the Minsky thing. That was like, hey, there's nothing we can't do. Provably there's nothing we can't do. And so that's kind of when I started getting involved in neural networks. So I was getting involved in the early 90s, and they were very widely used in industry. I was using them for the very boring things like targeted marketing for retail banks. There tend to be big companies with lots of money that we use it.
So I heard him say something kind of strange, that they're saying it could be used for any type of problem of any type of complexity. That I'm pretty sure is not known yet. Yeah, because of there's a P versus NP problem. There's a bounty out for this problem. If you watching this right now can solve this problem, you'll get $1 million. But it asks whether every problem whose solution can be verified quickly can also be solved quickly. Okay, so I guess I had a little bit of a misunderstanding as to what this was truly asking. It's not about whether or not problems can be solved. It's whether or not problems whose solutions can be verified can also be solved. It is at least what it says here. I personally don't have a good understanding of this problem, and if I did, I would probably be trying to cash in on this prize right now, because $1 million is still worth quite a lot.
And it certainly, though, was true that often the networks were too big or slow to be useful. They were certainly useful for some things, but they never felt to me like they were living up to promise for some reason. Now, what I didn't know, and nobody I personally met knew, was that actually there were researchers that showed 30 years ago that to get practical good performance, you need more layers of neurons. Even though mathematically, theoretically, you can get as accurate as you want with just one extra layer, to do it with good performance, you need more layers. So when you add more layers to a neural network, you get deep. Right? So deep doesn't mean anything like mystical, it just means more layers. More layers than just adding the one extra one. So thanks to that, neural nets are living up to their potential, as we saw in that, like, what's deep learning good at? So we can now say that Rosenblatt is right. We have a machine that's capable of perceiving, recognizing, and identifying surroundings without any human training or control. That's definitely true. There's anything controversial about that statement based on the current technology. So we're going to be learning how to do that. We're going to be learning how to do that exactly the opposite way of probably all of the other math and technical education you've had. We are not going to start with...
So this is kind of interesting to me, because I'm reading a book right now called 7 Habits of Highly Effective People. At least I was reading. I'm not really serious about reading it, but this this picture was used in that book, I believe. So I wonder if David Perkins has to do with that book at all. Oh yeah, so this is me. Stephen Covey was the writer of the book, so I don't know if this is related to David Perkins. I think it's just a stock photo that they both used.
A 2-hour lesson about the sigmoid function, or a study of linear algebra, or a refresher course on calculus. And the reason for that is that people who study how to teach and learn have found that it's not the right way to do it for most people. For most people, so we work a lot based on the work of Professor David Perkins from Harvard and others who work with us.
Okay, this is really interesting. I'm going to watch this at regular rate.
A lot of things. We talk about this idea of playing the whole game. And so playing the whole game is like, it's based on the sports analogy. If you're going to teach somebody baseball, you don't take them out into a classroom and start teaching them about the physics of a parabola and how to stitch a ball and a three-part history of 100 years of baseball politics, and then 10 years later, you let them watch a game. And then 20 years later, you let them play a game. Which is kind of like how math education is being done. Right? Instead, with baseball, step one is to say, hey, let's go and watch some baseball. What do you think? That was fun, right? See that guy there? He's trying to run there before the other guy throws the ball over there. Hey, you want to try having a hit? Okay, so you're going to hit the ball, and then I have to try and catch it, and then you have to run over there. And so, from step one, you're out playing the whole game.
Yeah, just to add to that, when people start, they're often may not have a full team or be playing full 9 innings, but they still have a sense of what the game is, kind of the big picture idea.
Yeah. So, there's lots and lots of reasons that this helps most human beings. Not everybody, right? There's a small percentage of people who like to build things up from the foundations and the principles. And not surprisingly, they are massively overrepresented in a university setting because the people who get to be academics are the people who thrive with the kind of, to me, upside-down way things are taught. But outside of universities, most people learn best in this top-down way, where you start with the full context. So number 2 in the 7 principles, I'm only going to mention the first 3, is to make the game worth playing. Which is like if you're playing baseball, you have a competition. You score. You try and win. You bring together teams from around the community and have people try to beat each other. And you have leaderboards, like who's got the highest number of runs.
I will just say that none of this seems like it would be something that a professor at Harvard would develop. It seems like something just a random person on the street would tell you about learning.
Or whatever, right? So this is all about making sure that the thing you're doing, you're doing it properly. You're making it the whole thing. You're providing the context and the interest. So for the fast AI approach to...
Also his mouse settings are really weird.
To learning deep learning, what this means is that today we're going to train models end to end. We're going to actually train models, right? And they won't just be crappy models. They will be state-of-the-art, world-class models from today. And we're going to try to have you build your own state-of-the-art, world-class models from either today or next lesson, depending on how things go. And then number 3 in the 7 principles from Harvard is work on the hard parts, which is kind of like this idea.
Wait, is that number 3 in the 7 principles? What are principles 4 through 7?
Of practice. Yes.
It's a deliberate practice.
Yeah, it's deliberate practice, right?
Yeah.
Work on the hard parts means that you don't just, swing a bat, at a ball every time, you go out and just muck around. But you train properly. You find the bit that you're the least good at. You figure out where the problems are, you work damn hard at it, right? So, in the deep learning context, that means that we do not dumb things down, right? By the end of the course, you will have done the calculus, you will have done the linear algebra, you will have done the software engineering of the code, right? You will be practicing these things which are hard. So it requires tenacity and commitment, but hopefully...
Shut up, time is ticking.
You'll understand why it matters, because before you start...
Alright, we're pumping it up to 1.5.
Practicing something, you'll know why you need that thing because you'll be using it. Like to make your model better, you'll have to understand that concept first. So, for those of you used to a traditional university environment, this is going to feel pretty weird. And a lot of people say that they regret, after a year of studying fast AI, that they spent too much time studying theory and not enough time training models to write code. That's the kind of like the number one piece of feedback we get. People who say, I wish I'd done things differently. It's that. So please try to, as best as you can, since you're here, follow along with this approach. We are going to be using a kind of software stack Sorry,
I just to say one more thing about the approach. I think since so many of us spent so many years kind of with the traditional educational approach with bottom up, that this can feel very uncomfortable at first. I still feel uncomfortable with it sometimes, even though I'm committed to the idea. And that some of it is also kind of having to catch yourself and be okay with the not knowing the details, which I think can feel very unfamiliar or even wrong when you're kind of new to that. Like, oh wait, I'm using something and I don't understand every underlying detail. You kind of have to trust that we're going to get to those details later.
So I can't empathize because I did not spend lots of time doing that, but I will tell you this, teaching this way is very, very, very hard. I very often find myself jumping back into a foundations-first approach because it's just so easy. Like, oh, you need to know this, you need to know this, you need to do this, and then you know this. That's so much easier to teach. So I do find it's much, much more challenging to teach, but hopefully it's worth it. We spent a long time figuring out how to get deep learning into something.
I will say I think there is a fundamental flaw with that other way. Now, the advantage I think is pretty obvious, and that's you don't have to deal with motivation. People understand why they're learning it, but what you might have is people learning to do it in ways that are not going to get them very far, and giving them an extra step where they have to unlearn the things they did that are going to prevent them from being successful, in addition to learning the necessary things. Where if they had just started by, learning a few fundamentals about baseball, maybe like keep your elbow up, or like some kind of, fundamental, like wear your glove on your catching hand, throw with your, and throw with your strong hand, not your weak hand. They might have been better off than if they just kind of wing it and then, oops, I did it wrong and I'm not going to be able to be as successful if I continue using this poor strategy. So it seems like there are some downsides to the other way, but I think for most people it's probably a better way, because a lot of people really question why they're learning something, and if they're just introduced to it, they like it, they're having fun doing it, those questions just kind of go out the door.
One of the things that helps us here is the software we have available. If you haven't used Python 4, it's a ridiculously flexible and expressive and easy to use language. We have plenty of bits about it we don't love, but on the whole, we love the overall thing. And we think it's, most importantly, the vast majority of deep learning practitioners and researchers are using Python. On top of Python, there are two libraries that most folks are using today, PyTorch and TensorFlow. There's been a very rapid change here. TensorFlow was what we were teaching until a couple of years ago. It's what everyone was using until a couple of years ago. It got super bogged down. Basically, TensorFlow got super bogged down. This other software called PyTorch came along that's much easier to use and much more useful for researchers. And within the last 12 months, the percentage of papers at major conferences that uses PyTorch has gone from 20% to 80%, and vice versa. Those who use TensorFlow have gone from 80% to 20%. So basically, all the folks that are actually building the technology we're all using are now using PyTorch. Industry moves a bit more slowly, but in the next year or two, you'll probably see a similar thing in the industry. Now, the thing about PyTorch is it's super flexible, and it really is designed for flexibility and developer friendliness. It's certainly not designed for beginner friendliness. And it's not designed for what we'd say, it doesn't have like higher level APIs, which I mean, there isn't really things to make it easy to build stuff quickly using PyTorch. To deal with that issue, we have a library called FastAI that sits on top of PyTorch. Now, FastAI is the most popular higher level API for PyTorch. It is, because our courses are so popular, some people are under the mistaken impression that FastAI is designed for beginners or for teaching. It is designed for beginners and teaching, as well as practitioners in industry and researchers. The way we do this, make sure that it's the best API for all of those people, is we use something called a layered API. And so there's a peer-reviewed paper that Sylvain and I wrote that described how we did that. And for those of you that are software engineers, it will not be at all unusual or surprising. It's just totally standard software engineering practices, but there are practices that were not followed in any deep learning library we've seen. Just basically lots of refactoring and decoupling. And so by using that approach, it's allowed us to build something which you can do super low level research, you can do state-of-the-art production models, and you can do kind of super easy beginner world-class models. So that's the basic software stack. There's other pieces of software we'll be learning about along the way. But the main thing I think to mention here is it actually doesn't matter. If you learn this software stack and then at work you need to use TensorFlow and Keras, say, you'll be able to switch with, in less than a week. Lots and lots of students have. have done that. It's never been a problem. The important thing is to learn concepts, right? And so we're going to focus on those concepts. And by using an API, which...
So I just want to say TensorFlow and Keras are ones that I've seen before. PyTorch and FastAI are pretty much new terms for me, but TensorFlow and Keras are things I've heard about before. Okay, and I want to take a quick break, fill up my water, and I will be back shortly.
Minimizes the amount of boilerplate you have to use. It means you can focus on the bits that are important. The actual lines of code will correspond much more to the actual concepts we're implementing. You are going to need a GPU machine. A GPU is a graphics processing unit, and specifically you need an NVIDIA GPU. Other brands of GPU just aren't well supported by any deep learning libraries. Please don't buy one. If you already have one, you probably shouldn't use it. Instead, you should use one of the platforms that we've already got set up for you. It's just a huge distraction to be spending your time doing like system administration on a GPU machine and installing drivers and blah, 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 right? And run it on Linux, please. That's what everybody's doing, not just us. Everybody's running on Linux. Like, make life easy for yourself. It's hard enough to learn deep learning without having to do it in a way that you're learning, all kinds of arcane hardware support issues. There's a lot of free options available, and so please use them. If you're using an option that's not free, don't forget to shut down your instance. So what's going to be happening is you're going to be spinning up a server that is somewhere else in the world, and you're going to be connecting to it from your computer and training and running your building models. Just because you close your browser window doesn't mean your server stops running on the whole. Right? So don't forget to shut it down, because otherwise you're paying for it. Colab is a great system, which is free. There's also a paid subscription version of it. Be careful with Colab. Most of the other systems we recommend save your work for you automatically. You can find out at any time. Colab doesn't. So be sure to check out the Colab platform thread on the forums.
Okay, that's really good to know. I didn't know that it didn't save it automatically. It looks like I'm in Colab right now, I think. I might be in the other one. Yeah, I'm in the other one. I'm not in Colab right now, but I'm going to shut this down because I think that is a good habit in case I do want to pay for it for whatever reason later. Just getting used to having good habits is important. Now this is not Colab, this is Gradient. So let's go into Colab. Okay, and let's make sure that I've got it saved. So, yep, let's go to Google Drive. So first I'm gonna need to move my, okay, I'm gonna need to move it into this one. Okay, so now, yep, we got the copy here. So, yep, everything is good to go. And it looks like you can skip the video and just do this. But let's keep watching the video.
To learn about that. So I mentioned the forums. The forums are really, really important because that is where all of the...
Okay, so let's bookmark the forums. So it's going to be forums.fast.ai.
Discussion and setup and everything happens. So for example, if you want help with setup, there's a setup help thread and you can find out how to best set up Colab and you can see discussions about it, you can ask questions. And please remember to search before you ask your question, right? Because it's probably being asked before, and that's all one of the very, very earliest people who are doing the course. So once you, step one is to get your server set up by just following the instructions from the forums or from the course website. The course website will have lots of step-by-step instructions for each platform. They will vary in price, they will vary in speed, they will vary in availability, and so forth. Once you're finished following those instructions, the last step of those instructions will end up showing you something like this, a course v4 folder, so version 4 of our course. And by the time you see this video, it's likely to have more stuff in it, but it will have an MBs, or notebooks folder, so you can click on that.
Okay, so we're at that step already, so let's follow along. So we'll click on that NBs. That's going to be in let's see here. So hopefully I bookmarked it. Code mentorship, machine learning. Nope, so I didn't bookmark it, but it's going to be I think it starts with a C. Starts with a G, I think. G-O. It should start with something. I don't know what letter it starts with. Let me go into my history. But it definitely is going to start with a letter. I mean, it could start with a symbol, but... Paperspace, is that it? Okay. Oh, okay. Yeah, it starts with a G. It's gradient, but apparently it's not gradient. It's paperspace. So we're gonna need to start it again. It's definitely a good habit to stop it, but you've got to start it again, and it actually takes a few minutes to start. So it's really not ideal, but. Okay, so maybe we can open it beforehand. Well, we can just have it sit here. Okay, so let's keep watching the video.
And that will show you all of the notebooks, of course. What I want you to do is scroll to the bottom and find the one called Attribute. You can click on that.
Okay, so he's getting quite a bit ahead of me. So let me. And I think what I might do is just follow along on my second screen. So it's not going to show up in this video, but you'll just kind of have to take my word for it that I'm doing everything he's doing. And I can come back, check in every once in a while, and show that my results are the same. But you just won't see me doing them. So it looks like my notebook is still powering up. Okay, I'm going to pause it quick. I'll be right back. Alright, so I just needed a quick break there. I am back. Let's see. Okay, so I'll show you what I'm looking at. I'm trying to start it up again. I think it is good habit to shut it down, but unfortunately you've got to wait for it to start up again. And so far it has taken more than 2 minutes, so it's definitely not a trivial amount of time to just stop it and restart it. So. Okay, so now we're 3 minutes in and it's still starting. Yeah, I think that's too much of a cost of time to establish that good habit. Having a good habit, it's something called premature optimization. I'm really not planning to pay for this service ever, so establishing a good habit to optimize when I would pay for it just doesn't make a lot of sense if it's costing me this much time. So I'm just going to leave it up from now on. I'm not going to hit that stop button because otherwise that would be premature optimization. Okay, so we're still waiting. I think I might pause it and come back once it's up, so I will see you then. Okay, so I am back. I've got the door open a little bit. I'll close it so it doesn't slam and spook me like it did before. You can see I took a 25-minute break. It didn't take all 25 minutes for it to go into running mode. It did take a good 5 to 10 though, so I'm definitely going to forego building that good habit that I would need if I were paying for this in the name of minimizing premature optimization, and just keep this running as much as possible. So let's try to follow along with the video, and as I said before I took a break, I'm going to be following along on my second monitor, so it won't be displayed, but you'll just kind of have to take my word for it that I am following along with him. And eventually I will check in and show what I'm looking at.
And this is where you can start. Jupyter Notebook. What is Jupyter Notebook? Jupyter Notebook is something where you can start typing things.
Okay, so he says I can start typing things. I don't see how I can do that. You'll notice I was able to follow along here, but he said you can start typing things, but it's pretty clear that in fact I cannot start typing things right now without some extra special kind of yeah, so this is not accurate. Oh, I think it's because I just have an HTML screenshot. Yep, I clicked on the wrong thing. I got to click on the .ipynb file here. Okay, so now I can just start typing whatever I want. Okay, so but let's do maybe a Control Z or some sort of edit, remove cells. So it looks like it's a okay, well they gave me a hotkey here to remove a cell, and it's DD, but I'm not sure. That obviously did not seem like it would work. So maybe Control DD, Control Shift D, Control Shift DD. Yeah, I'm not sure what this hotkey means. It's not working. Okay, but yep, well, we're on the same page, so I'm gonna hide my own work and continue going.
And press Shift Enter, and it will give you an answer. And so everything good? Typing is Python code, and the thing that comes up is the result of that code. And so you can put in anything in Python. X equals 3 times 4, x plus 1, and as you can see, it displays the result anytime there's a result to display. So for those of you that have done a bit of coding before, you will recognize this as a REPL, R-E-P-L, read, evaluate, print, look. Most languages have some kind of REPL. The Jupyter Notebook REPL is particularly interesting because it has things like headings, graphical outputs, interactive behavior. It's a really astonishing piece of software. It's won some really big awards. It's I would have thought the most widely used REPL outside of shells like Bash. It's a very powerful system. We love it. We've written our whole book in it. We've written the entire class A library with it. We do all our teaching with it. It's extremely unfamiliar to people who have done most of their work in IDE. You should expect it to feel as awkward as perhaps the first time you moved from a GUI to a command line. It's different, right? So if you're not familiar with kind of REPL-based systems, it's going to feel super weird. but stick with it because it really is great. The kind of the model going on here is that this web page I'm looking at is letting me type in things for a server to do and show me the results of computations the server is doing. So the server is off somewhere else, not running on my computer, right? The only thing running on the computer is this web page. But as I do things, so for example, if I say x equals x times 3, this is updating the server's state. There's this state that's like, what's currently the value of x? So I can find out now x is something different. So you can see, when I did this line here, it didn't change the value of x plus 1. Right? So that means that when you look at a Jupyter notebook, it's not showing you the current state of your server. It's just showing you what that state was at the time that you printed that thing out. It's just like if you use a shell like bash. And you type ls, and then you delete a file. That earlier ls you printed doesn't go back and change. Right? That's kind of how REPLs generally work, including this one.
Okay, so I just want to show what I'm doing here. I'm actually having a lot of trouble just following along. He says you can just simply type things, but I found that if I do that, it doesn't really kind of predictably behave. Like there, I typed the same thing basically I typed last time, and it just put a bunch of hash signs there. Here I'm gonna, here I'm typing 1, 2, 3, 4, 5, and I'm just getting hash signs. So I do not find this right now very intuitive, and the way it's working for him is not similar to the way it's working for me.
Jupyter Notebook has two modes. One is edit mode, which is when I click on a cell, and I get a flashing cursor, and I can move left and right and type.
Okay, so that's edit mode. Let's practice edit mode. So we're going to click on a cell. So now I'm in edit mode. So let's learn about the other mode.
There's not very many keyboard shortcuts in this mode. One useful one is Control or Slash, which will comment, comment.
Control slash. Okay, yeah, that's working for me. Let's keep going.
The main one to know is Shift Enter to actually run.
Yep, Shift Enter I've used a bunch.
So, at that point there's no flashing cursor anymore, and that means that I'm now in command mode on my head.
Okay, but so let's go to command mode. Okay, I'm in, I hit Shift Enter, so I'm in command mode.
So as I go up and down, I'm selecting different cells. So in command mode, as we move around, we're now selecting cells, and there are now lots of keyboard shortcuts to use. So if you hit H, you can get a list of them. So for example, you'll see that they're not on the whole like Control or Command with something, they're just that on its own. So if you use like Vim, you'll be more familiar with this idea. So for example, if I can C to copy, and V to paste, and it copies the cell. Or X to cut it, A to add a new cell above. And then I can press the various number keys to create a heading. So number 2 will create a heading number 2. And as you can see, I can actually type formatted text, not just code. The formatted text I type is
Okay, so the reason it wasn't working for me is because I was in this special mode here. So I wasn't in the mode I thought it was, where I could enter in numbers like 1, 2, and 3. I was in a mode where I entered the heading here.
in Markdown.
Okay, so let's try to follow along with what he's doing here. So we're going to need to create, we're going to stay in this mode. But let's add a new section. So we'll hit this plus sign. We'll insert a cell. Okay. Okay, and then we'll try. Okay, so that's just a cell. So we actually didn't want to insert a cell, I think. Yeah, so there's cells and then there's things that aren't cells. This is not a cell. So if we do delete cells, this will not be deleted. Okay, well obviously that's not true, it is a cell. So let's insert a cell below. Now let's see if we can. See, I want a cell like this, where it's just, it doesn't have this in here. Here we go. So it looks like, yeah, so I can use this to change the kind of cell. So, perfect. Okay, so let's change this to a heading cell. But okay, this is actually a legacy option that doesn't do anything. So we've only got 3 options. Let's use a markdown cell, and then we'll say my cell. Okay, and then I'll hit Shift Enter. This takes me out of this special insert mode where I can use my arrow keys within a cell. And now my arrow keys just jump through. So now if I want a different cell with a different mode, code mode, I can have that here. And now I can do print hello world and Shift Enter. And now I've got actual code input and output, but if I were to click back on this and create another cell, you can see I get that where it's like this, but I just go to this drop down here and I can get I can change it from a code cell to this. So that's really important to know. That's something he didn't say yet, but that's a big reason why I was unable to follow along. Okay. So let's see here. Heading, list, numbered. Okay, let's just keep watching.
Like so. Might not work.
Okay, so the fact that he doesn't explain that there's multiple kinds of cells is kind of upsetting to me. That could have saved me a lot of time and confusion.
There you go. So that's a Markdown. If you haven't used Markdown before, it's a super useful way to write formatted text that is used very widely. So learn it because
Markdown is not a difficult thing that requires a lot of extra explanation. The differences between the cells and the fact that there are 3 different kinds of cells you can use, that requires a detailed explanation. Not Markdown, because there's a lot of extra documentation about that you can look up yourself.
super handy. And you need it for Jupyter. So when you look at our book notebooks, for example, you can see an example of all the kinds of formatting and code and stuff here. So you should go ahead and go through the app Jupyter, and you can see here how you can create plots, for example, and create lists of things, and import libraries, and display pictures, and so forth. If you want to create a new notebook, you can just go new -3, and that creates a new notebook, which by default is just called an eyeball, so you can then rename it to get whatever name you like. And so then you'll now see that in the list here, new name. The other thing to know about Jupyter is that it's a nice easy way to jump into a terminal if you know how to use a terminal. You certainly don't have to for this course, at least for the first bit. If I go new terminal, you can see here I have a terminal. One thing to note is for the notebooks are attached to a GitHub repository. If you haven't used GitHub before, that's fine. But basically, they're attached to a server where from time to time we will update the notebooks on that server. And you'll see on the course website and the forum, we tell you how to make sure you have the most recent versions. When you grab our most recent version, you don't want it to conflict with or overwrite your changes. So as you start experimenting, it's not a bad idea to like select a notebook and click duplicate, and then start doing your work in the hub. And that way, when you get an update about latest course materials, it's not going to interfere with the experiments that you've been running.
Okay, so I don't think I'm going to need to do that because I've got it saved in my own Google Drive. If I expand this out and I go down to Okay, that might have actually been the other one. So yeah, that might be something I need to take note of, is the fact that updates could affect my changes.
So there's two important repositories to know about. One is the Fastbook repository, which we saw earlier, which is kind of the full book with all the outputs and prose and everything. And then the other one is the Course v4 repository, and here is the exact same notebook for the Course v4 repository. And for this one, we remove all of the prose and all of the pictures and all of the outputs, and just leave behind the headings and the code. In this case, you can see some outputs because I just ran that code, but most of it, there won't be any. Oh no, I guess we have 50 outputs. I'm not sure if we're going to keep that or not, so you may or may not see the outputs. So the idea with this is probably the version that you want to be experimenting with, because it kind of forces you to think about like what's going on as you do each step, rather than just reading it and running it without thinking. We kind of want you to do it in this more bare environment, in which you're thinking about like, oh, what did the book say? Why was this happening? And if you forget, then you can kind of go back to the book. The other thing to mention is both the Course v4 version and the Fastbook version at the end have a questionnaire. And quite a few folks have told us, that, amongst the reviewers and stuff, that they actually read the questionnaire first. We spent many, many weeks writing the questionnaires, Sylvain and I. And the reason for that is because we tried to think about, like, what do we want you to take away from each notebook? So if you kind of read the questionnaire first, you can find out what are the things we think are important, what are the things that you should know before you move on. So rather than having like a summary section at the end saying, at the end of this you should know blah, 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 we instead have a questionnaire to do the same thing. So please make sure you do the questionnaire before you move on to the next chapter. You don't have to get everything right. And most of the time answering the questions is as simple as going back to that part of the notebook and reading the prose. But if you've missed something, like, do go back and read it, because we're assuming, these are the things we're assuming you know. So if you don't know these things before you move on, it could get frustrating. Having said that, if you get stuck after trying a couple of times, do move on to the next chapter. Do 2 or 3 more chapters and then come back. Maybe by the time you've done a couple more chapters, you'll get some more perspective. We try to re-explain things multiple times in different ways. So yeah, it's okay if you try and you get stuck, then you can try and move on.
Okay, so unfortunately I think this video is just a 1.5 hour video telling you that you are meant to do something else besides watching this video. So I kind of don't know if I want to just ditch this video and try doing the thing he's telling me I actually need to do. And this was just a red herring, false flag, wild goose chase, this actual video. But I think I'm just going to watch the video to the end, but I will state that I'm very confused right now if I am caught up for Monday by watching this video, or if I could have skipped watching the video and just done the actual instructions in the notebook.
Alright, so let's try running the first part of the notebook. So here we are in 01 intro. So this is chapter 1. And
oh, perfect. Okay, so he is gonna walk us through actually doing the notebook. So the video and the notebook can be done in tandem, which is definitely what I was rooting for. So I was thinking, oh, this video is just 1.5 hours of him telling us to do something else. But nope, by the time I'm done watching this video, I'll be all caught up for Monday.
Here is the cell. So I click on the cell.
Okay, so let's click on the cell. So this is going to be running your first notebook, okay? And I'm going to click on the cell. So one thing that's really important that he has not talked about yet is this drop down here, because this tells you the type of cell you have. And sometimes it is obvious because you've got this in, but on cells like these, you're not going to know whether it's a markdown cell or a raw NB convert cell unless you look at this drop down. So this is probably, I would say, the most important thing to know about. once you click on a cell, is what kind of cell it is. Code cells are going to be obvious, but the markdown cells might not be as obvious. Okay, so this is where he's at. So let's continue learning.
And by default, actually there will be a editor toolbar, as you can see, you can turn on and off. I always leave them off myself. And so to run. Under this cell, you can either click on the play or run button, or as I mentioned, you can hit Shift Enter. So for this one, I'm click. And as you can see, the star appears, because it says I'm running, and now you can see a progress bar popping up. That's going to take a few.
Okay, so I'm not having the same kind of luck he's having. When I click on run, it just simply skips down to this next cell. It looks like it doesn't actually do anything. If I click here, run this cell, it similarly does absolutely nothing, but in that case it doesn't even go down to the next cell. So let's see if my code looks the same as his. Okay, and it does. So I wonder if it's because I haven't run the first cell.
Yes. Okay.
Okay, so now hopefully this cell will run a lot better. Nope, still didn't run. Okay. Why didn't it run? Okay. Why didn't it run? Okay, so there's obviously a pretty big problem where his is running but mine is not. So, because he gets a special bar here that I don't have, and if I go back a little bit,
Just leave them off myself. And so to run this cell, you can either click on the play or run button.
And he's even got a different run button than I have. My run button looks completely different, and he's not showing it properly. But he might even have some extra output that I don't have. Because you can see I have, if my computer will allow me to use it, which sometimes it does not, especially when it's hotter in here. I don't have any extra output under this box, but he does, certainly after he clicks the run button, and he's got a different run button than I do. But you can see there's obviously something very wrong. I think one of the things that might have gone wrong is I might have forgotten to toggle it over to GPU. But that might be on the other server where I needed to do that. I can't remember. Okay, I do have some extra notebooks running, so we can shut this one down. Okay, and this is the one that we're working on right now. Okay, so it looks like it's not running. Let's try it in the other thing, but let's make sure we got this paper space bookmarked. Okay, and then let's find the other one. So I'm going to go back to the course to find it. Okay, and then notebook servers. So this is Gradient. Let's take a look at Collab and see if that works. Oh, and before we do that, let's go to the account that I want to use. Okay, and we'll click Runtime, change runtime type to GPU, and save. Okay, and now I've got different things than he has. He has one called running your first notebook. I don't have that. Yeah, I don't have anything like that, so I guess I'm more interested in figuring out how to get this to work. Now, one thing that was strange is if I click run on it, it actually takes away the output. So there's very clearly something very wrong happening. Maybe it has to do with this not trusted. Ah, so I think that's it. We've got to trust the notebook. Okay, so now that it's trusted, hopefully we'll have better results. Nope, it's still not working. So one thing you'll notice is that he's running the notebook on a special server that he has, and he's not using the Gradient paper space thing that I'm using. So it looks like he has a special setup there that I don't have. But I thought there would be a way to get it to work. I'm gonna pause it and I'll be back shortly. Okay, so I am back. I did get it to work somehow. Like I saw the progress bars moving, but then I immediately kind of like ruined it. So let's see if I can get those progress bars to move again. Nope. Okay, so let's see if I can get, because I did see the progress bars moving and then all of a sudden they stopped moving. Okay, so now it's green. Okay, so I can see that I can have it be green, I can have it be blue, or I can have it be non-selected. So when it's green and I hit the run, what happens? Okay, nothing happens. Alright, when it's blue and I hit the run, what happens? Nothing happens. Okay, now can I make this one green and blue? I can't, I can only make it blue. Okay, so I did see these progress bars come up, but unfortunately, I don't know how I saw them came up, and I clicked again, and that additional click caused them to go away. Okay, I clicked run all, and I still did not see this run at all. So let's run the cell and select below. Okay, and that's what this does. It looks like it runs and selects below. Yep, and you can see that shows up. So I did see this trigger, but I'm not sure. Perfect. So now it's working. I don't know how it's working, but I did restart the kernel. That did seem to help things. So yeah, so it's working now. Okay, so I'm gonna pause it. I'll be back shortly. All right, I am back. Everything completed correctly. We do have an error rate. We do have, but I think that's what's to be expected. So let's keep watching the video.
So this one is quick. And as you can see, the star appears. So it says I'm running, and I can see a progress bar popping up. That's going to take a few seconds. Okay? And so as it runs, it's going to print out some results. Don't expect to get exactly the same results as us. There's some randomness involved in training the model, and that's okay. Don't expect to get exactly the same time as us.
Yeah, so one thing I noticed is my times took longer than his. It looks like my error rates were about the same, a bit higher for the first one, a little bit lower for the second one. But my times were definitely longer. I think he's probably using more powerful gear than I am.
If this first cell takes more than 5 minutes, unless you have a really old GPU, that's probably a bad sign. You might want to hop on the forums and figure out what's going wrong. Or maybe you're trying to use Windows, which really doesn't work very well at this moment. Don't worry that we don't know what all the code does yet. We're just making sure that we can train a model. So here we are, it's finished running. And so as you can see, it's printing out some information. And in this case, it's showing me that there's an error rate of 0.005 at doing something. What is the something it's doing? Well, what it's doing here is it's actually grabbing a dataset, we call it pets dataset, which is a dataset of pictures of cats and dogs, and it's trying to figure out which ones are cats and which ones are dogs. And as you can see, after about well less than a minute, it's able to do that with a 0.5% error rate. So it can do it pretty much perfectly. So we've trained our first model. We have no idea how, we don't know what we were doing, but we have indeed trained a model. So that's a good start. And as you can see, we can train models pretty quickly on a single computer, which many of which you can get for free. one more thing to mention is if you have a Mac, it doesn't matter whether you have Windows or Mac or Linux in terms of what's running in the browser, but if you have a Mac, please don't try to use that GPU. Macs actually, Apple doesn't even support NVIDIA GPUs anymore, so that's really not going to be a great option. So stick with this, it'll make life much easier for you. Well, actually, the first thing we should do is actually try it out. So I claim we train a model that can pick cats, from dogs. Let's make sure we can. So let's check out this cell. This is interesting, right? We've created a widgets.file upload object.
All right, so let's try running the next cells. Yep, we ran this. It worked perfect, so it should be ready to go. This is just a markdown cell, so it doesn't have any code in it. So let's run this 1+1 cell, make sure we don't get the... Aha! So we didn't get the same issue where it just does nothing and moves on. So I think this is going to be the same code he was running. Nope, he's got uploader equals widgets. So that's the next one. So let's run this cell. It's an additional cell he didn't run. But yep, here we got a nice cat image. So we'll go down to the next one here and run that. So now we've got this upload 0. So let's see what he has to say.
And display it. And this is actually showing us a clickable button. So as I mentioned, this is an unusual REPL. We can even create GUIs in this REPL. So if I click on this file upload, and I can pick cat. There we go. And I can now turn that uploaded data into an image.
Okay, so let's do this. Let's find a random picture of a cat, and let's see if I can identify it as such. So we're gonna do images. Oh, I like that one. So that was a good one. So we'll go with this one. Really zenful, peaceful cat. I like that. That's kind of how I'm feeling today. Things are going better. I got my diet under control, so no longer super fat. So this cat looks like it's ahead of me. Looks like a pretty fit cat. So we're going with this one. All right, and we'll say cat. And we'll save it to the desktop for now. I can just delete it later. And now we'll upload this into my Paperspace console. Oh, they're faking it, but I cannot fake it. I can just use. So here we had img equals. Yeah. So this cell here, which is a code cell, is faking it, but I don't need to fake it. I've got the real image. So let's delete this cell. Okay, and now it looks like he modified his. Yeah, he modified his by putting it in its own cell. So let's do that as well. So we're going to insert a cell on top. Oh. Yeah, so we're going to insert a cell above. Okay, and then we're going to move this code over to that cell. All right, and then I think we can run. Well, yeah, we can run that code, and then the next line we're going to print out the image. So let's run this code. Okay, and then now let's insert another cell above, and then this line I think he's going to print that image out, but we'll see what he actually does.
There's a cat, and now I can do predict.
Exactly. So yep, he printed that out. So let's do that likewise, and we'll see we've got a different cat than he's got. Oops. So it didn't. Oh. Yep. So here we go. It just took it some time to think. So yep, we got the custom cat image that I uploaded. So let's continue watching the video.
And it's a cat with a 19.
All right, so here's the moment of truth. Let's see if it can recognize that this here is a cat and with what level of confidence it has. A okay, that's interesting. So is this a cat? True, and it's 100% confident that it's a cat. That's pretty impressive. Let's try a different file. So let's just upload a different pic. Let's upload a baby pic of my my nephew, and we'll see if he is a cat or not. So let's try to keep the pic flattering. I think this is a flattering pic, so we'll go with that one. Oops, and it looks like we've got 2 of them uploaded now. So how do I like unrun a cell? What does this mean? Okay, restart the kernel. Okay, yeah, so we'll restart the kernel. These are now broken, so we can get rid of those. Okay, so yep, and you can see these don't have stars next to them anymore. Yep, so they haven't been run yet. But we're restarting the cell and we're running it again. So, and we're going to upload a new image that isn't an image of a cat, and we're going to see if it thinks it's a cat or not. Okay, but it's got to do those 2 data training set things. So I'd like to eat a tortilla while it's doing that, so I might pause it and do that and then come back. All right, I am back, and our data model is finished training. So this next part I will run, and this next part I will run again as well. Oops, so it looks like I accidentally ran the data trainer again. So I'm going to need to wait for that to finish. Okay, I'm not sure why that happened though, because I clicked run cell select before, and I thought the next, because right now this is not a selected cell. This cell down here is selected, so I don't know why this one ran. Okay, but here you can see it's not working. That's because it's already running this one up here. Okay, but now it's done. So yep, now it can process this output. Now here's the okay. So yep, now we got to the picture of the cat here, but that's not related. Let's upload. What does this mean? Interrupt the kernel. Okay, so let's upload the picture of my the flattering picture of my new nephew. We'll perhaps not upload this one. We'll choose this one here. And then let's go ahead and run the code here. Okay, and then we'll run this here, and we should see a picture. Uploader is not defined. Oh, I never ran this. Okay, yeah. So now I would choose the flattering picture, not a picture such as this one here. A picture down like that one. Okay, and then I would run this next part here. Okay, and now I can run this cell. Okay, so now this is not a cat, it is a 4-month-old baby. So let's see if, nope, it's a cat. So my nephew is a cat. The machine intelligence said that it is so it must be true. Okay, so, okay, well, I'm pretty sure he's not a cat, so there is something wrong with my machine learning code. I think that's more likely. I haven't seen him in person yet because I'm in Texas here and COVID-19 and stuff, but I would be really surprised if I showed up and these were just pictures of an actual cat. So let's go and okay, well, you know what, let's just forget about it and let's make a post on on Discord, because this is kind of funny. Alright, so let's continue on. Okay.
9.96% probability. So we can see we have just uploaded an image that we picked out. So you should try this, right? Grab a picture of a cat, find one from the internet, or take a picture of one yourself, and make sure that you get a picture of a cat. This is something which can recognize photos of cats, not line drawings of cats. And so as we'll see in this course, these kinds of models can only learn from the kinds of information you give it. And so far we've only given it, as we'll discover, photos of cats, not animated cats, not drawn cats, not abstract representations of cats, but just photos. So we're now going to look at what's actually happened here. And you'll see at the moment I'm not getting too great information here. If you see this in your notebooks, you have to go File, Trust Notebook. And that just tells Jupyter that it's allowed to run the code necessary to display things, to make sure there isn't these query problems. And so you'll now see the outputs. Sometimes you'll actually see some weird code like this. This is code that actually creates outputs. And so sometimes we hide that code, sometimes we show it. So generally speaking, you can just ignore the stuff like that and focus on.
Okay, so I'm not sure how to hide the code. I do have what he's got right here, but it would be interesting to hide this input, but I don't know how to do that. It's definitely not as easy as he seems to be making it, but of course I am using console paperspace and not a university donated super machine, like probably on my desk. So, but let's see if we can hide that, because I think that will help things. Now, why does this have... Okay, because you could scroll through the output. Okay. Now it's green. Is there a way to hide Okay, I don't know how to hide a cell. Let's see if, yeah, I'm not sure how to do that. So I guess I'll just, it's not a big deal. It's not like the code's not running or anything. So I'll just keep my cells unhidden. And you know, he's saying that he's hiding a cell. He's being a bit dishonest when he says that. He's not hiding a cell. He's hiding the input within a cell. The input and output are one single cell. It's not two cells. So he misspoke there.
So I'm not going to go through these. Instead, I'm going to have a look at same thing over here in slides. So what we're doing here is we're doing machine learning. Deep learning is a kind of machine learning. What is machine learning? Machine learning is just like regular programming. It's a way to get computers to do something. But in this case, like, it's pretty hard to understand how you would use regular programming to recognize dog photos from cat photos. How do you kind of create the loops and the variable assignments and the conditionals to create a program that recognizes dogs versus cats in photos? It's super hard. Super hard. So hard that until kind of the deep learning era, nobody really had a model that was remotely accurate at this apparently easy task. Because we can't write down the steps necessary. So normally, we write down a function that takes in inputs and goes through our program and gives us some results. So this general idea where the program is something that we write the steps doesn't seem to work great.
All right, let's read this. So machine learning is, like regular programming, a way to get computers to complete a specific task. But how would you use regular programming to do what we just did in the last section? Recognize dogs versus cats, but not do it. Oh, I guess it has to be a dog or a cat. It can't be a 4-month-old baby. Normally, it's easy enough for us to write down the steps to complete a task when we're writing a program. In general, we write a function that looks something like this.
For things like recognizing pictures. So back in 1949, somebody named Arthur Samuel started trying to figure out a way to solve problems like recognizing pictures of cats and dogs. And in 1962, he described a way of doing this. Well, first of all, he described the problem. Programming a computer for these kinds of computations is at best a difficult task. Because of the need to spell out every minute step of the...
Okay, so let's actually read the quote. So programming a computer for such computations is, at best, a difficult task. Not primarily because of any inherent complexity in the computer itself, but rather because of the need to spell out every minute step of the process in the most exasperating detail. Computers, as any programmer will tell you, are giant morons, not giant brains.
The process in exasperating detail. Computers are giant morons, which all of us coders totally recognize. So he said, okay, let's not tell the computer the exact steps, but let's give examples of a problem to solve and figure out how to solve it itself. And so by 1961, he built a checkers program that had...
So let's read this. So his basic idea was this. Instead of telling the computer the exact steps required to solve a problem, instead show it examples of the problem to solve and let it figure out how to solve it itself. This turned out to be very effective. By 1961, his checkers playing program had learned so much that it beat the Connecticut state champion. Here's how he described his idea from the same essay as above. Suppose we arrange for some automatic means of testing of effectiveness of any current weight assignment in terms of actual performance and provide a mechanism for altering the weight assignment so as to maximize the performance. We need not go into the details of such a procedure to see that it could be made entirely automatic and to see that a machine so programmed would learn from its experience.
Beating the Connecticut state champion, not by telling it the steps to take to play checkers, but instead by doing this, which is arrange for an automatic means of testing the effectiveness of a weight assignment in terms of actual performance, and a mechanism for altering the weight assignment so as to maximize performance. This sentence is the key thing, and it's a pretty tricky sentence, so we can spend some time on it. The basic idea is this. Instead of saying inputs to a program and then outputs, let's have inputs to what's called the program now model. It's the same basic idea, inputs to a model and results. And then we're going to have a second thing called weights. And so the basic idea is that this model is something that creates outputs based not only on, for example, the state of a checkers board, but also based on some set of weights or parameters that describe how that model is going to work. So the idea is, if we could enumerate all the possible ways of playing checkers, and then describe each of those ways using some set of parameters or what else called weights, then if we had a way of checking how effective a current weight assignment is in terms of actual performance, in other words, does that particular enumeration of a strategy for playing checkers end up winning or losing games? Right? And then a way to alter the weight assignment so as to maximize performance. So then, let's try increasing or decreasing each one of those weights one at a time to find out if there's a slightly better way of playing checkers, and then do that lots of times. Then eventually, such a procedure could be made entirely automatic. And then the machine so programmed would learn from its experience. So this little paragraph is the thing. This is machine learning, right? A way of creating programs such that they learn rather than they're programmed.
So we can now see why he said that a procedure could be made entirely automatic and a machine so programmed would learn from its experience. Learning would become entirely automatic when the adjustment of the weights was also automatic. Instead of us improving a model by adjusting its weights manually, we relied on an automated mechanism that produced adjustments based on performance. Figure 1-6 shows the full picture of Samuel's idea of training a machine learning model.
So, if we had such a thing, then we would basically now have something that looks like this. You have inputs and weights again, going into a model, creating results, i.e. you won or you lost, and then a measurement of performance. So remember that's this key step, and then the second key step is a way to update the weights based on the measure of performance, and then you can look through this process and train a machine learning model. So this is the abstract idea. So after we've run that for a while, right, it's come up with a set of weights that's pretty good. Right? We can now forget the way it's trained, and we have something that's just like this, right? Except the word programs now replaces the word model. So a trained model can be used just like any other computer program. So the idea is we're building a computer program not by putting out the steps necessary to do the task, but by training it to learn to do the task, at the end of which it's just another program. And so this is what's called inference, right? It's using a trained model as a program to do a task such as playing checkers. So machine learning is training programs developed by allowing the computer to learn from its experience rather than through manual code. Okay, how would you do this image? What is that model and that set of weights such that as we vary them, it could get better and better at recognizing cat sets as dogs? I mean,
Okay, so it is not at all obvious what the model might look like for an image recognition program, or for understanding text, or for many other interesting problems we could imagine. What we would like is some kind of function that is so flexible that it could be used to solve any given problem just by varying its weights. Amazingly enough, this function actually exists. It's the neural network. A mathematical proof called the universal approximation theorem shows that this function can solve any problem to any level of accuracy in theory.
For checkers, it's not too hard to imagine how you can kind of enumerate, like, depending on different kinds of how far away the opponent's piece is from your piece, what should you do in that situation, how should you weight defensive versus aggressive strategies, blah, blah, blah. Not at all obvious how you would do that in image recognition. So what we really want is some function in here which is so flexible that there's a set of weights that could cause it to do anything. Really, like the world's most flexible possible function. And it turns out that there is such a thing. It's a neural network. So we'll be describing exactly what that mathematical function is in the coming lessons. To use it, it actually doesn't really matter what the mathematical function is. It's a function which is, we say, parameterized by some set of weights, by which I mean, as I give with a different set of weights, it does a different task. And it can actually do any possible task. Something called the universal approximation theorem tells us that mathematically crudely, this functional form can solve any problem that is solvable to any level of accuracy, if you just find the right sequence. Which is kind of restating what we described earlier.
So a mathematical, okay, so bring on the neural networks. A mathematical proof called the universal approximation theorem shows that this function can solve any problem to any level of accuracy in theory.
We would deal with the Minsky problem. So, neural networks are so flexible that if you can find the right sort of weights, they can solve any problem, including is this a cat or is it a dog?
Bring on SGD, I don't know what that stands for, stochastic gradient descent. The fact that neural networks are so flexible means that in practice they are often a suitable kind of model, and you can focus your effort on the process of training them, that is, of finding good weight assignments. But what about that process? What we'd like here as well is a completely general way to update the weights of a neural network and make it improve at any given task conveniently This exists. This is called stochastic gradient descent, SGD. Jeremy says, don't worry, neither SGD nor neural nets are mathematically complex. Both SGD and neural nets nearly entirely rely on addition and multiplication to do their work, but they do a lot of addition and multiplication. The main reaction we hear from students when they see the details is that all it is?
So that means you need to focus your effort on the process of training them, that is finding good ways that scientists use us in this terminology. So how do you do that? We want a completely general way to do this, to update the weights based on some measure of performance, such as how good is it at recognizing cats versus dogs. And luckily it turns out such a thing exists. And that thing is called stochastic gradient descent, or SGD. Yeah, we'll look at exactly how it works, we'll build it ourselves from scratch, but for now we don't have to worry about it. I will tell you this though. Neither SGD nor neural nets are at all mathematically complex. They nearly entirely are addition and multiplication. The trick is it just does a lot of them, like billions of them, so many more than we can intuitively grasp. They can do extraordinarily powerful things. But they're not rocket science at all. They're not complex things. And we'll see exactly how they work. Right. So that's the Arthur Samuel version. Right? Nowadays we don't use quite the same terminology, but we...
Okay, so Samuel was working in the 1960s, but terminology has changed. Here is the modern deep learning terminology for all the pieces we have discussed. The functional form of the model is called its architecture, but be careful, sometimes people use model as a synonym of architecture, so this can get confusing. The weights are called parameters. The predictions are calculated from the independent variables, which is the data, not including the labels. The results of the model are called predictions. The measure of performance is called the loss. The loss depends not only on the predictions, but also the correct labels, also known as targets or dependent variable, e.g. dog or cat.
It's exactly the same idea. So that function that sits in the middle we call an architecture. An architecture is the function that we're adjusting the weights to get it to do something. That's the architecture. That's the functional form of the model. Sometimes people say model to mean architecture, so don't let that confuse you too much, but really the right word is architecture. We don't call the weights, we call them parameters. Weights has a specific meaning, it's quite a particular kind of parameter. The things that come out of the model, which make the architecture with the parameters, we call them predictions. And the predictions are based on two kinds of inputs. Independent variables, that's data, like the pictures of the cats and dogs. And dependent variables, also known as labels, which is like the things that exist for the cat, so the dog, the cat. So that's your inputs. The results of predictions. The measure of performance, to use Arthur Samuel's word, is known as the loss. So the loss is being calculated from the labels and the predictions. Okay. And then there's the update back to the parameters. Okay, so this is the same picture as we saw, but just putting in the words that we use today.
Why did they change the words? Just use the same words. Or use the better words. Just, I don't understand why everything always has to change all the time.
So this picture, if you forget, if I say these are the parameters of this, used for this architecture to create a model, you can go back and remind yourself what are the parameters, what are the predictions, what is the loss? Okay, the loss is some function.
I wouldn't have had to do that if you just introduced it with the correct term.
That measures the performance of the model in such a way that we can update the parameters. So, it's important to note that deep learning and machine learning are not magic, right?
Alright, so limitations inherent to machine learning. From this picture, we can now see some fundamental things about training a deep learning model. A model cannot be created without data. A model can only learn to operate on the patterns seen in the input data used to train it. This learning approach only creates predictions, not recommended actions. It's not enough to just have examples of input data. We need labels for that data too, e.g. pictures of dogs and cats aren't enough to train a model. We need a label for each one, saying which ones are dogs and which are cats.
The model can only be created where you have data showing you examples of the thing that you're trying to learn about. It can only learn to operate on the patterns that you've seen the input used to train it. Right? So if we don't have any line drawings of cats and dogs, then there's never going to be an update to the parameters that makes the architecture, and so the architecture and the parameters together is the model, so we say the model, that makes the model better at predicting line drawings of cats and dogs, because they never receive those web updates, because they never receive those inputs. Notice also that this learning approach only ever creates predictions. It doesn't tell you what to do about it. And that's going to be very important when we think about things like a recommendation system, like what product do we recommend to somebody? Well, I don't know, we don't do that, right? We can predict what somebody will say about a product after we've shown them, but we're not creating actions, we're creating predictions. And that's a super important difference to recognize. It's not enough just to have examples of input data like pictures of dogs and cats. We can't do anything without labels. And so very often organizations say we don't have enough data. Most of the time they mean we don't have enough labeled data. Because if a company is trying to do something with deep learning, often it's because they're trying to automate or improve something they're already doing. Which means by definition they have data about that thing, or a way to capture data about that thing, because they're doing it. Right? But often the tricky part is labeling it. So for example, in medicine, if you're trying to build a model for radiology, you can almost certainly get lots of medical images about just about anything you can think of. But it might be very hard to label them according to a malignancy of a tumor, or according to whether or not meningioma is present, or whatever, because these kinds of labels are not necessarily captured in a structured way, at least in the US medical system. So that's an important distinction that we can discuss. So then a model, as we saw from the PDP book, a model operates in an environment, right?
All right, I'm going to eat another tortilla, so I'll pause it and I'll be back. Okay, I'm back. The tortilla was a freaking lifesaver. It was delicious. It's gone. So let's continue.
You roll it out and you do something with it. And so then this piece of that kind of PDP framework is super important, right? You have a model that's actually doing something. For example, you build a predictive policing model that predicts, doesn't recommend actions, it predicts where an arrest might be made. This is something a lot of jurisdictions in the US use.
Okay, Mr. Ethics guy. Wow, okay, we're already starting in with as gray as a ethics territory as you can get into.
Predicting that based on data and based on label data. And in this case, it's actually going to be using, in the US, for example, data where I think, depending on whether you're black or white, black people in the US I think get arrested something like 7 times more often for, say, marijuana possession than whites, even though the actual underlying amount of marijuana use is about the same in the two populations. So if you start with bias data and you build a predictive policing model, its prediction will say, oh, you will find somebody you can arrest here based on some bias data. So then law enforcement officers might decide to focus their police activity on the areas where those predictions are happening, as a result of which they'll find more people to arrest. And then they'll use that to put it back into the model, which will now find, oh, there's even more people we should be arresting in the black neighborhoods, and thus it continues. So this would be an example of how modeling interacting with this environment to create something called a positive feedback loop, where the more a model is used, the more biased it becomes, making the modeling more biased, and so forth. So one of the things to be super careful about with machine learning is recognizing how that model is actually being used and what kinds of things might happen as a result of that.
I was just going to add that this is also an example of proxies, because here arrest is being used as a proxy for crime. And I think that pretty much in all cases, the data that you actually have is a proxy for some value that you truly care about. And that difference between the proxy and the actual value often ends up being significant.
Thanks, Rachel. That's a really important point. Okay, so let's finish off by looking at what's going on with this code. So the code we ran is basically 1, 2, 3, 4, 5, 6 lines of code. So the first line of code is an import line. So in Python, you can't use an external library until you import from it. Normally in Python, people import just the functions and classes that they need from a library. But Python does provide a convenient facility where you can import everything from a module, just by putting a star there. Most of the time, this is a bad idea, because by default, the way Python works is that if you say import star, it doesn't only import the things that are interesting and important in the library you're trying to get something from, but it also imports things from all the libraries it used and all the libraries they used, and you end up kind of exploding your namespace in horrible ways and causing all kinds of bugs. Because FastAI is designed to be used in this REPL environment where you want to be able to do a lot of quick, rapid prototyping, we actually spent a lot of time figuring out how to avoid that problem so that you can import star safely. So whether you do this or not is entirely up to you, but rest assured that if you import star from a FastAI library, it's actually been explicitly designed in a way that you only get the bits that you actually need. One thing to mention is in the video you see it's called FastAI 2. That's because we're recording this video using a pre-release version. By the time you're watching the online, the MOOC version of this, you will have the 2 will be gone. Something else to mention is...
Okay, so I'm just going to verify that the 2 is gone from mine.
there are, as I speak,
Yep, the 2 is gone from mine.
4 main predefined applications in Fast AI, being vision, text, tabular, and library filtering. We'll be learning about all of them and a lot more. For each one, say here's vision, you can import from the .all kind of meta module, as we could call it, and that will give you all the stuff that you need for the most common vision applications. So if you're using a REPL system like a Jupyter Notebook, it's going to give you all the stuff right there that you need without having to go back and figure it out. One of the issues with this is a lot of Python users don't, if they look at something like untitled data, they will figure out where it comes from by looking at the import line. And so if you import star, you can't do that anymore. But the good news is, in the REPL, you don't have to. You can literally just type the symbol, press shift enter, and it will tell you exactly where it came from, as you can see.
Alright, so let's try that. So it's going to be untar data. So let's add a... oh, we're not going to move. I don't know why they have moving as a hotkey. Like inserting, to me, would be something more useful than moving. But let's do untar. Oops. So it looks like I was in the wrong mode. It looks like I just entered a bunch of hotkeys. One of them was to create a new cell, and another one was to change it to this format of cell. So we're not going to need this cell here, so let's remove it. Okay, so I'm not sure how to remove this cell. Maybe the scissors. I guess I can do a cut. There we go. Yeah, there we go. And now I'm in the cell. The cell is green, so I'm in the proper mode to enter stuff into the cell. So let's do untar, untar underscore data, and then was it the tab key twice? I forget what he did. Let's see what, or was it the enter key? I think he hit the enter key. So it's going to be shift enter. Yeah, so you can, and then it'll tell you where it came from. So it came from Fast AI data external. Which I'm surprised it didn't come from Fast AI Vision all. Yeah, I'm really surprised by that. But it matches what he has, so let's just continue watching.
See, so that's super handy. So in this case, for example, to do the actual building the data set, we call image data loaders from main func. And I can actually call the special doc function to get the documentation for that. And as you can see, it tells me exactly everything passed in, what all the defaults are, and most importantly, not only what it does, but show in docs pops me over to the full documentation, including.
Okay, so let's figure out how to do that. So he ran the special docs function.
View exactly where it came from, as you can see. So that's super handy. So in this case, for example.
Okay, so it looks like he clicked on the cell underneath that cell. So I'm going to do that. Okay, so oh, it looks like he's got 2 cells underneath. Oh, I see. So yeah, he typed out this here in advance. That's why it went so fast, because he typed it out in advance. So let's insert a cell above. Okay, and then now I'm going to change that cell green. And you can't see what I'm doing because it's on a different screen, but I'm going to need it on this screen. For now. I can go back and kind of redo what I did. So if I were to do this again, I could just go down here, insert a cell above, and then make sure that the cell is green, so I'm not firing hotkeys at it and getting all confused and making a bunch of changes I didn't intend. So, and then it's DOC, image, data loaders, from name, func. There we go, and now I can do a shift enter to run that, and I've got exactly what he's got. And I can click here just as he did and go get the fast AI documentation for this. So that's really nice. Yep, closes really easy with the X. I'll remove this one because the duplicate isn't necessary. Okay, I'm not sure how to delete a cell, but I do know how to cut the cell, which is basically the same thing. Okay, so let's keep watching the video.
To do the actual building the data set, we call image data loaders from name func. And I can actually call the special doc function to get the documentation for that. And as you can see, it tells me exactly everything to pass in, what all the defaults are, and most importantly, not only what it does, but show in docs pops me over to the full documentation, including an example. Everything in the FastAI documentation has an example, and the cool thing is, the entire documentation is written in Jupyter Notebooks. So that means you can actually open the Jupyter Notebook for this documentation and run the line of code yourself and see it actually working and look at the outputs and so forth. Also in the documentation, you will find there's a bunch of tutorials. So for example, if you look at the addition tutorial, it'll cover lots of things. One of the things we'll cover is, as you can see in this case, pretty much the same kind of stuff we're actually looking at in this one. So there's a lot of documentation in FastAI, and taking advantage of it is a good idea, but it's fully searchable. And as I mentioned, that's most importantly, every one of these documentation pages is also a fully interactive Jupyter Notebook. So looking through more of this code, the first line after the import is something that uses Untitled. That will download the dataset, decompress it, and put it on your computer. If it's already downloaded, it won't download it again. If it's already decompressed, it won't decompress it again. And as you can see, FastAI already has predefined access to a number of really useful datasets, such as this text dataset. Datasets are a super important part, as you can imagine, with deep learning. We'll see lots of them, and these are created by lots of heroes who basically spend months or years collating data that we can use to build these models. The next step is to tell FastAI what this data is, and we'll be learning a lot about that. In this case, we're basically saying, okay, it contains images. It contains images that are in this path. So untitled data returns the path that is whereabouts it's been decompressed to, or it's already decompressed to, tells us where it was previously decompressed to. We have to tell it things like, okay, what images are actually in that path. One of the really interesting ones is the label function. How do you tell for each file whether it's a cat or a dog? And if you actually look at the README for the original data set, it uses a slightly quirky thing, which is they say, oh, anything where the first letter of the file name is uppercase is a cat. That's what they decided. So we just created a little function here called isCat that returns the first letter is uppercase or not. And we tell FastAI that's how you tell it's a cat. We'll come back to these two in a moment. So the next thing, so now we've told it what the data is. We then have to create some called a learner. A learner is
with the first letter of the what?
Called isCat that returns the first letter is uppercase or not. And we tell FastAI that's how you tell it's a cat.
Oh, so it's only going to tell you whether it's a cat or a dog based on if the name of the file is uppercase or lowercase and not anything within the file? Am I understanding that correctly?
We'll come back to these two in a moment. So the next thing, so now we've told it what the data is. We then have to create some called a learner. A learner is a thing that learns, it does the training. So you have to tell it what data to use. And then you have to tell it what architecture to use. We'll be talking a lot about this in the course. But basically, there's a lot of predefined neural network architectures that have certain pros and cons. And for computer vision, the architecture is called ResNet. Just a super great starting point, so we're going to use a reasonably small one. So these are all predefined and set up for you. And then you can tell FastAI what things you want to print out as training. And this is tell us an error, please, as you train. So then we can call this really important method called fine-tune that we'll be learning about in the next lesson, which actually does the training. Valid percent does something very important. It grabs, in this case, 20% of the data, 0.2 portion, and does not use it to train the model. Instead, it uses it to tell you the error rate of the model. So always in FastAI, this metric, error rate, will always be calculated on the part of the data which has not been trained with. And the idea here, and we'll talk a lot more about this in future lessons, the basic idea here is we want to make sure that we're not overfitting. Let me explain. Overfitting looks like this. Let's say you're trying to create a function that fits all these dots. Right? A nice function would look like that. Right? But you can also, you can actually fit it much more precisely with this function. Look, this is going much closer to all the dots than this one is. Right? So this is obviously a better function. Except, as soon as you get outside where the dots are, especially if you go off the edges, it obviously doesn't make any sense. So this is what you call an overfit.
So when you train a model, you must always have both a training set and a validation set, and must measure the accuracy of your model only on the validation set. If you train for too long with not enough data, you will see the accuracy of your model start to get worse. This is called overfitting. FastAI defaults valid underscore PCT to 0.2. So even if you forget, FastAI will create a validation set for you.
So overfitting happens for all kinds of reasons. We use a model that's too big, or we use not enough data. We'll be talking all about it, right? But really, the craft of deep learning is all about creating a model that has a proper fit. And the only way you know if a model has a proper fit is by seeing whether it works well on data that was not used to train it. And so we always set aside some of the data to create something called a validation set. The validation set is the data that we use not to touch it at all when we're training a model, but we're only using it to figure out whether the model's actually working or not. One thing that Sylvain mentioned in the book is that one of the interesting things about studying FastAI is you learn a lot of interesting programming practices.
Okay, so let's read what Sylvain actually said. Throughout my time studying fast.ai, and even still today, I've learned a lot about productive coding practices. The FastAI library and fast.ai notebooks are full of great little tips that have helped make me a better programmer. For instance, notice that the FastAI library doesn't just return a string containing the path to the data set, but a path object. This is a really useful class from the Python 3 standard library that makes accessing files and directories much easier. If you haven't come across it before, make sure to check out its documentation or a tutorial and try it out. Now that the book.fast.ai website contains links to recommended tutorials for each chapter, I'll keep letting you know about little coding tips I've found useful as we come across them. And then NB nota bene, FastAI does not show a traditional approach to Python programming. If you code in Python at work, follow your organization's style and practices. FastAI incorporates ideas from Lisp, APL, math, and many other languages and notations, and uses approaches customized for data science.
So I've been programming since I was a kid, so 40 years. And Sylvain and I both work really, really hard to make Python do a lot of work for us and to use programming practices which make us very productive and allow us to come back to our code years later and understand it. And so you'll see in our code, we'll often do things that you might not have seen before. And so a lot of students who have gone through previous courses say they learn a lot about coding and Python coding and software engineering from the course. So yeah, check it out. When you see something new, check it out. And feel free to ask on the forums if you're curious about why something was done that way. One thing to mention is, just like I mentioned, like import star is something most Python programmers don't do because most libraries don't support doing it properly. We do a lot of things like that. We do a lot of things where we don't follow a traditional approach to Python programming. Because I've used so many languages over the years, I code not in a way that's specifically Pythonic, but incorporates like ideas from lots of other languages and lots of other notations. And heavily customize our approach to Python programming based on what works well for data science. That means that the code you see in FastAI is probably not going to fit with the kind of spiral guides and normal approaches at your workplace if you use Python there. So obviously, you should make sure that you fit in with your organization's programming practices rather than following ours. But perhaps in your own hobby work, you can follow ours and see if you find that interesting and helpful, or you can experiment with that in your company if you're a manager and you're interested in doing so. Okay, so to finish, I'm going to show you something pretty interesting, which is, have a look at this code. Untitled data, image data loaders from namefunc, learner, fine-tune. Untitled data, segmentation data loaders from labelfunc, learner, fine-tune. Almost the same code, and this is a built model that does something, totally different.
Okay, so let's open up that part. I had closed mine. I wanted to look at the data set because I was just curious. So let's go back to the root here and let's go to the course. We'll go to NBS. Okay, so images. So chapter 1 cat example. Go back to MBS. Okay, we'll go to the intro here. Okay, so the next part is going to be this deep learning is not just for image classification. Okay, so let's okay, I don't see the same thing he's got there, but okay, so learn show results. That's a result of that. So let's run these code blocks here. So let's run this one. Oops, so it looks like we've got a problem here. Untar data is not defined. Yep, so I think it's because these previous steps weren't run. So this one's going to take a little bit of time to come up. I think the reason it wasn't coming up before was because I just wasn't giving it enough time to come up. But we should have untar data now that we did all that. We can probably even skip all of these steps. Yeah, we can skip all of those steps. Just once the model is trained, then we'll be good. So URLs, pets, /images. Okay, so images, yeah, so there's really nothing in here. There's a grizzly bear. There's a particularly photogenic grizzly bears too. Like normally grizzly bears look like kind of ugly. Like they have like super long snouts and like they're pretty thin. Oh, bear. Like this is more what I think of when I think of a grizzly bear, or like these two. Like these are more like the fake, like picturesque. Alright, well, let's stop looking at pictures of grizzly bears. I guess there's... Okay, now that this is done, let's move on. We do have this untar data now. Let's verify that. Yep, we've got it now. So let's go down here and let's run this code here. Okay, and then we'll do learn.show results. Perfect, we've got it.
It's something which has taken images. This is on the left, this is the label data. It's got images with color codes to tell you whether it's a car, or a tree, or a building, or a sky, or a line marking, or a road. And on the right is our model. And our model has successfully figured out which pixel. Is that a car, a line marking, a road? Now, it's only done it in under 20 seconds, right? So it's a very small, quick model. It's made some mistakes, like it's missing this line marking, and some of these cards it thinks is house, right? But you can see, so if you train this for a few minutes, it's nearly perfect. But you can see the basic idea is that we can very rapidly, almost exactly the same code, create something not that classifies cats and dogs, but does what's called segmentation. It figures out what every pixel in the image is. Look, it's the same thing from import star text loaders from Clover. Learn.
Okay, so this one looks like it's using, it's duplicating the image. So let's go back to where I ran it, which is right here. And you can see we've got an image on the left and we've got an image on the right. And it's just trying to duplicate the image on the left by copying every pixel. And it's not perfect, but it's pretty darn close. So I ran this cell here, but it didn't do anything. It says if you hit a CUDA out of memory error after running this cell, click in the menu on the menu kernel, then click on the menu kernel, then restart. Instead of executing the cell above, copy and paste the following code in it. This reduces the batch size to 32. Well, let's just try, because I never got that error, it just didn't run. Okay, so now it ran, but of course it's going to have all sorts of problems because I didn't do the steps before. So I think it's complaining about utils. Let's try it again now that I've got that utils. Nope, so we've got no storage data. So I think it's because I didn't run the, it's because I didn't run this here. So let's run that. Oops, yep. All right, and then we'll do this learn.show results. Okay, we got the same thing again. It looks like we got two different images this time. Okay, and now let's see if this works. Oh, nope, we still got the same problem here. And it's a file not found error. It's not a out of memory error. It's a file not found error. I think it's because I didn't run this stuff. So let's try running that. Then we'll try running this. This one takes forever, but we'll try it. Okay, I'm going to pause it. I'll be right back. Alright, so welcome back. This video is going on 2.5 hours, but I have videos on my channel that are like 4 hours or longer. So let's keep going. Hopefully we can finish this soon. It looks like the video is only another half an hour long or so. So I did get it to work, I think. Did I or did I not? Nope, I did not. So, yeah, we've got this problem here that I'm looking through. It looks like there's no such file or directory. So, oh yeah, what I was doing is I was just making sure that all the code is running. So let's just keep doing that. So run. Make sure all the code has run, because that could be the problem, is that some prior step needed to run that was not run. Okay, this I don't think we'll need to. Well, I mean, even here, let's just give it a cat photo. Okay, now let's, we're going to see this change. Yep, so now it's the cat photo I had. We're going to see this change. So, yep, it is a cat for sure. Okay, now this stuff we won't need to run again. But this one, I think we'll just run that again. Might take a little bit of time. I think it was faster than the other one, though. But the other one just takes a lot of time. Yeah, this one should only take like 30 seconds. Okay, so now let's take a look at the results. Okay, and the reason I wasn't seeing them all is because I didn't have this scroll bar selected. So I can select the scroll bar and scroll down. Oh, but even so, I'm just getting 2 of them. All right, let's see if this works now. Nope, so we still got this problem where we have no such file or directory. So let's try replacing it with this code and see if it works. Okay. Okay, so let's try this code instead. Nope, so we still got the same problem where we've got no such file or directory, storage, data, counter. So let's see if that is true, that we don't have that. And if it is true, let's try to create that. Yeah, so we do have storage, we do have data. Do we have imdb_tok? We do. Okay, and do we have counter.plk? Nope. So sure enough, we don't have that. So let's try to get that somehow. I'm not sure how we can get it. Now, if I were, yeah, let's open a new terminal. Yep, and then we'll open a bash shell. So we'll go bash. Okay, and then we'll go just here and we'll do a find-name, and we'll see if we've got this anywhere at all. If we have it, we can just change where it's looking for it. Yeah, so it should be untar data URLs dot imdb. Okay, so this isn't working for some reason. Usually just a simple find doesn't take this long. Let's narrow down the search just so it's not searching so much. We know it's going to be storage data here, so let's search in here to see if we've got it. Okay, so now we can do a find dash name counter.pkl. Nope, so we don't have it. So I guess I can create it. I'm not sure what's meant to be in it. Now this is a pickle file, so yeah, I'm not sure what this file is meant to be. No such file or directory. So I guess let's just make the file. Okay, and we'll just leave it blank for now, and hopefully it works. Okay, so we ran out of input. I'm not sure what kind of input it's going to need. So this is definitely different from this CUDA. But let's try maybe restarting this, and then running this again. Oh, so same thing, ran out of input. Okay, so I'm gonna delete this, and then try running it again, and I think I'll post in the Discord that I'm finally hosed. Okay, let's let's just search for this on Google, because maybe somebody, loading data bunch fails. So let's see if, so data equals data bunch. Is that the problem I'm having? Nope, that's not the problem I'm having. Let's do a Google search for this line, because it might show up in their forms. Okay, let's take a look at this file not found error in Google. Yeah, so it can't find that file, but I thought it would have that file. Yeah. So I mean, I know what's happening. It's that it can't find this file, but we can see that the file is missing from there, but I don't know how to get the file. Maybe it's under storage, data, IMDb, like test or something. Okay, no such file or directory. Storage, data, IMDb, TOK. Oops. Let me try to, okay, there we go. So it's going to be storage, data, IMDb, TOK. So yep, sure enough, we don't have that file. Maybe it's in a different. Let's go to adult sample. What does that mean? Let's not look at that. Let's go to terminal, and then let's open bash, and we're gonna do storage, data, and then find dash name on that file, counter.pickle. Nope, so we just don't have that pickle file. And I don't know why, like, we should have that file. Here we go. So, yep, somebody had this problem in the forum. Yep, so he's got the same thing I've got. Oh, okay. I see. So try writing the path in a separate line and perform commands on the path. So it looks like there's something wrong with the line here. So we're gonna take this this part out, and then we're gonna say path equals, and then we're going to write path here, and let's see if that works. Nope. So same problem. Oh, okay. So it looks like what I need to do is delete the full imdb_tok folder. Yep. So let's delete that. So rm-r imdb_tok. Okay. So now let's try running this again. We can keep the modification. It doesn't matter. Yeah, perfect. Now it works. Okay. So this looks like it's going to take a while. In fact, it looks like it has an estimated time of like 10 minutes. I'm going to come back in like 10 minutes. Let's see if there's more video I can watch. Yeah, let's just watch some more video and then we'll come back.
Basic code. This is now something where we can give it a sentence, and it can figure out whether that is expressing a positive or negative sentiment. And this is actually giving a 93% accuracy on that task in about 15 minutes on the IMDb dataset, which contains thousands of full-length movie reviews, like 1,000 to 3,000 word movie reviews. And this number here that we got with the same 3 lines of code would have been the best in the world for this task in a very, very, very popular academic dataset in like 2015, I think. So we are creating world-class models in our browser using the same basic code.
Okay, so that's pretty cool. I'm going to pause the video and come back when that's done, and we'll see it more in action. As I've got it now, it's churning the data. It's got another 8 minutes to go, so I will be back shortly. Alright, so I'm back. It looks like it's still training. I've got a hard cutoff at like 5:55, maybe 6, but I want to use the gym. I'm not going to actually use the gym with the coronavirus and everything, but I want to swim the lake behind my apartment. And the lake closes at 7. It takes me about a half an hour, 45 minutes to swim it, so I want to do it at 6. I think in the past I've been kind of not honoring that late close time, so I want to make sure I'm doing that going forth so that I don't get called out. They're nice enough not to call me out on it yet. Let's go ahead and, oh yeah. So I just wanted to bring in that update. It's still going, so we're gonna have to wait for that to finish before we can finish this course. It is 45 minutes away, and we've only got a little bit of video left, so I'm hoping this can finish, and I can finish all of chapter 1 until before 6. So I'm going to pause it again, and then I'll come back once it's finished training the model. All right, welcome back. So I've got the results now, so I can move on and keep working on this. Let me run the next one as well. So we've got Learn.Predict. I really liked that movie. So we've got POS, Tensor 1. But let's keep watching the video. Hopefully we can finish it by 6.
Here's the same basic steps again from import star, untitled data, tabular data loaders, from CSV, learner, fit. This is now building a model that is predicting, let's find out, salary based on a CSV.
Okay, so he moved ahead. I kind of fell behind a little bit. So this is sidebar, that order matter, and then this is end sidebar. So let's run the end sidebar code. Okay, so we might need to wait a little bit for it. Oh wait, no. So we're good. So now let's run the next one. Aha, so now we're training a model. Okay, so let's watch the video while this is training.
Table containing these columns. This is tabular data. Here's the same basic steps from import star.
Okay, so yep, we got that table, we got tabular data, just like he showed. We got cat names, we've got cont names, but you can see we've got results just like he had there. So let's run this next one. Okay, and now let's show some results just like he had. Okay, so let's keep watching.
Data, collect data loaders from CSV, learner, and fine-tune. This is now building something which predicts for each combination of a user and a movie what rating do we think a user will give that movie based on what other movies they've watched in the past. It's called collaborative filtering in these recommendation systems. So here you've seen some examples of each of the 4 applications in FastAI. And as you'll see throughout this course, the same basic code and also the same basic mathematical and software engineering concepts allow us to do vastly different things using the same basic approach. And the reason why is because of ArtSensible. It's because of this basic description of what it is you can do if only you have a way to parameterize a model and you have an update procedure which can update the weights to make you better at your loss function. And in this case, we can use neural networks, which are totally flexible functions. So that's it for this first lesson. It's a little bit shorter than other lessons are going to be. And the reason for that is that we are, as mentioned, at the start of the global pandemic here, or at least in the West. In other countries, they're much further into it. So we spent some time talking about that at the start of the class. And you can find that video elsewhere. So in future lessons, there will be more time on deep learning. So what I suggest you do over the next week before you work on the next lesson is just make sure that you can spin up a GPU server, shut it down when it's finished, if you can run all of the code here, and as you go through it, see, is this using Python in a way you recognize, use the documentation, use that doc function, do some searching of the FastAI docs, see what it does, see if it can actually grab the FastAI documentation, the books themselves, and run them. Just try to get comfortable, that you kind of can know your way around. Because the most important thing to do with this style of learning, this top-down learning, is to be able to run experiments, and that means to be able to run code. So my recommendation is don't move on until you can run the code, read the chapter of the book, and then go through the questionnaire. We still got some more work, some more stuff.
Wait, I've got to read the chapter and do the questionnaire. So you've got to do the questionnaire, you've got to read the chapter, you've got to watch the video, and you've got to run the code. So there's 4 steps that you can only do after you've watched the 2-hour video. So I finished. These people don't understand how time works. Either that, or they just think time works differently, and they just like. I think what's going on is academics like to say, oh, you're gonna spend 40 hours doing this thing. They like to. It's like pretentiousness. It's like, oh, you're gonna spend 10 hours working on this thing, but like anyone who is ever successful anywhere on that subject found the way to do it in less time. So they kind of tell you that you need to spend more time on it than they themselves have spent on it, I think. Like, and yeah, there's such thing as crunch time. Like, I have no doubt that PhD candidates spend a lot of time on their dissertations, but spending, having step 1 of a 4-step process for an introductory machine learning course be watch a 130 hour, a 1.5 hour video, and then once you're done with that, read an entire chapter, that's absurd. Like, I gotta get to the gym at 6.
So you won't be able to do all of it yet, but try to do all the parts that you can based on what we've seen, of course, so far. Rachel, anything you want to add? Okay, so thanks very much for joining us. So lesson 1, everybody, and I'm really looking forward to seeing you next time, where we will learn about transfer learning, and then we will move on to creating an actual production version of an application that we can actually put out on the internet, and you can start building apps that you can show your friends and they can start playing with. All right, bye everybody.
I mean, I started working on this at like 8 in the morning, and I'm done at about like 6. So I've been working on it for about 10 hours today. And pretty much all I've accomplished was running all the code and watching the video. I didn't read through the chapter. Let's see what. Okay, so actually it looks like I did read through the chapter. Yeah, because that was just. Okay, so I did everything. He just made it kind of confusing because he made it seem like if you watch the video, you still have more to do. But I don't think that's the case. If you watch the video, he goes through the whole chapter. You did the chapter, you did the code. So you should be fine. I think there does seem to be a lot more content here in this chapter than was shown in the video, which is a little bit frustrating. But that's, I mean, as far as what's in mind, like, I don't see that extra content. So, I think that's it. I think I'm good to go for Monday. So, let's just quickly try to answer some of these questions. So do you need these for deep learning? Lots of math. So they would say false, but I would actually disagree with them and say true. He, in the same room, in fact, they shared a microphone together. He called her over, had somebody who wrote 10 books on math. So he had lots of math by way of this person. Do you yourself need to know lots of math? Not necessarily if you've got a math person you're working with. Lots of data. So that's that one was pretty interesting because yes, you need lots of data, but often the problem is not that you don't have enough data. The problem is that you don't have enough categorization and labeling of your data. So that was interesting, but I would say that's true based on what I learned. I know if I were in a class and I marked down false, I would get it wrong and I would get an F, and then I wouldn't be able to get into a university and pay $100,000 in debt. But just now doing my self-learning, I would say true. Yeah, you do need a lot of data to do deep learning. Lots of expensive computers, absolutely true. I mean, you don't need to own it yourself, but like, look at what we're running. We looked at the parts. It was $10,000 for just a graphics card. So yes, you need access to lots of expensive computers. Now, do you yourself have to be responsible for that access? No, and you can use free solutions. So these are really trick questions because do you need lots of math? Not necessarily if you have access to somebody who knows a lot of math. Do you need lots of data? Not necessarily if you already have a data set and you've labeled it really well. Do you need lots of expensive computers? Well, of course you do, but you don't necessarily have to own them. And the last one, PhD. This is another one where I would say, yeah, you probably do need a PhD if you want to work at a major company, or you want to work for the government or something with machine learning in a really professional, high-level capacity. I would say, yeah, you need a PhD. So if I were in school, I would say F on all of these because he told us to say F. But based on what he taught me and what I learned from him, absolutely true. I mean, I just don't think the message he was trying to deliver was successfully delivered because one, he had in the same room and every time he spoke to me, I watched it. I often watched it in extra speed because he just wasn't, I thought, doing a great job of saying what he needed to say. But every time this math genius who wrote 10 books spoke, it blew my mind how clear everything was, how relevant everything was. You do need that math mentality, and I believe he has it. Like he said he had a degree training in philosophy. There's math and philosophy are kind of two sides of the same coin, really. They're related in a lot of ways. So yeah, you absolutely need lots of math, and you absolutely need lots of data. I mean, the IMD database was huge. Like, yeah, there are exceptions where you don't need that much data, but not that much data is still a lot of data. Expensive computers, I already went through that one. Of course you need that. PhD, yeah, if you want a job in the field, I would say you do. So, I mean, this will be interesting to talk about, and I'll bring this up on Monday. But again, if I were to get credit on this course that I could use to get into an expensive school and go into debt for the rest of my life, I would have F marked for all of these. But just based on what I learned from this course, I really think T is what I would mark these. Okay, so name 5 areas where deep learning is now the best in the world. I'm actually going to mark these because okay, so yeah, I'm on a separate line. I'm going to say T. He had a math genius with him. A math mentality is critical. Openness to math is critical. Lots of data. I would say, I mean, this one more, you could convince me false, but T, most deep learning requires lots of data, lots of expensive computers. I would say T. The NVIDIA cards cost up to easily. Okay, a PhD. T. Good luck getting hired with that one. Okay. Alright, so now name 5 areas where deep learning is now the best in the world. Biology, so like protein folding, which I don't really know that much about. Of course, automated driving. Oh, what's another one? Probably like facial recognition. Probably like email spam filters, and then like chatbots. Okay. What was the name of the first device based on the principle of the artificial neuron? I have no idea. I'd have to look at that. I have to look it up. Now this is just a draft, so it could be that he took out some of the stuff in chapter 1 and put it in chapter 2, which is why it's so much different here than it was over there. Okay, so the name of the first device was the Mark I perceptron. Okay, based on the book of the same name, what are the requirements for parallel distributed processing? Oh, so there's 8 requirements. So it has all 8 of these requirements. So it's going to be a set of processing units, a state of activation, an output function for each unit, a pattern of connectivity among units, a propagation rule for propagating patterns of activities through the network of connectivities, an activation rule for combining the inputs in pinging on a unit with the current state of that unit to produce an output for the unit, a learning rule whereby patterns of connectivity are modified by experience, an environment within the system must operate. Okay, so the next one is going to be, what are the 2 theoretical misunderstandings that held back the field of neural networks? And off the top of my head, I think I know this. I think the first one is that they didn't understand that you could use neurons together to overcome the limitation of a single one. And then I forget the other one, but I'm going to end the video here because I need to get to the gym at 6, do a swim, and then do some more exercise. I could probably come back to this later tonight, but I'm going to end it here, and then when I come back, I'll be finishing the rest of these questions, and then I'll be good to go for Monday. Alright, so that's the end of this video. Thanks for watching, and stay tuned for the next one.